Okay, I think we can actually kick off. Good morning, everyone. Happy Friday. I hope you had a really great week. I hope you're keeping safe, you're keeping productive, and more importantly, keeping sane during this lockdown. Um, and thank you for joining me for this series titled Intelligent Stormwater Design with Civil 3D and Devotech Iris. And it's hosted by me. I am Shoaib Yunus. I am the BIM Technical Specialist for Civil Infrastructure and Mining here at Baker Baines. And I decided, hey, let's put together a really nice series that'll help fellow civil infrastructure designers, water professionals to design and make a better world. So let's have a look at an overview of what the series entails. So what you're seeing there on the right hand side is a model that I've created in InfraWorks. We will touch on this later on in the actual webinar. But this is a three-part webinar series focusing only on stormwater design. All right. Part one, or today, we're going to be looking at or focusing on the modeling and layout aspect of the stormwater network. You're going to see how insightful this combination of technology makes design. Uh, Trust me, it's really good. Part two, we'll be looking at analysis because if your part one or your setting out of the stormwater network is not done correctly, you're going to get a lot of errors in the analysis phase. And then, of course, part three will be focusing on plan production, drawing production, and quantification. So, this is more or less how you would do it in consulting as well. And being in the consulting environment, being a civil design engineer as well, I know more or less the process how you would apply it in office. Right, so now that you've got an idea of the direction of this actual series, let's look at today's session, what we're going to be covering. So, of course, we always give an intro on who we are as Baker Baines. So, just a quick intro on that. Then we're going to jump into Civil 3D and Devotech IDIS because a lot of people do not know what IDIS is, who developed it, and what it can do for you. So, I'm just going to give you a brief intro on that to see what a great product this actually is and how much better it makes Civil 3D in total. Um, and then after, we're going to jump into intelligent stormwater design, the first part of the actual webinar series, where we're going to look at using South African pipe catalogs, plotting the network much more intelligently, checking for errors, checking the flow directions, checking for vertices, and applying inlet structures and stuff like that. So really good webinar, a lot of talking, a lot of technical explanation, but I'm sure that you all will keep up. And then, of course, we're going to conclude and let you kick off your early weekend if you're having one. But yeah, it is Friday, so you should be having a much more chilled of a day. All right, so let's look at who we are as Baker Baines. As you can see, our motto is helping you design and make a better world, and we do live by that. These are the four main key segments that we actually help you with. So we do survey, design, and hardware consultancy, and a big part of that is a scan to BIM workflow. So we deal with the hardware and the software and the workflow and the process. So we are end-to-end providers of that. We also are a design software consultancy firm where we are an Autodesk Gold partner. We have over 5,000 active licenses that we do manage, and those are international as well because of global license agreements. And then, of course, we also partner with technologies we feel that are great and will help you to design much more better. In terms of the blended learning provider segment, we are a firm believer of blended learning, be it online, be it face to face, be it whichever means are necessary. And we have partnered with CAD Learning, which I will touch on later. We're also an authorized Autodesk training center. So we provide face to face training either at our premises or at your workspace or now online due to current circumstances. And then, of course, we also help to improve your business processing and consulting. And what we do that is we have the tools, we have the expertise available, and that's why we are an Autodesk service provider select. It's a very niche market to be a part of. It just shows that we have the right professionals in the right spheres or fields to help you design and make a better world and to get your processes up and running much more efficiently. In terms of the market segments, these are characterized in 5 ways. First one being build. So build will be more or less the vertical segment, so all of your skyscrapers, your buildings, your structural buildings, residential housing, those type of things all fall under build, and architecture as well being the biggest segment of build. And then of course we got civil engineering and mining, or civil infrastructure and mining. That's my segment which I'm heading up, and I provide a lot of content, training, guidance, insight, and consulting on that. And then of course energy also is quite closely related to mining and manufacturing, so we do have specialists in engineer energy field as well as the product design and manufacturing field. And it's really close to civil now because uh, with prefabrication, or I call it Lego construction, a lot of things are pre-made or prefab, and then you bring it to the construction site and assemble. So these are the segments that we support, and it's literally all major segments throughout the world. In terms of the technology that we back or we support, of course, everyone knows Autodesk. They start off with AutoCAD, and then it's very popular, still most popular software in the world because of its presence. However, there are much more advanced and much more better software available now, being such as Civil 3D, which you can be seeing today, Revit, Inventor, Plant 3D, 3ds Max. There's a whole ton of software that can help you design a world much more smarter and much more enjoyably. And then of course we look at the 3D scanning and laser scanning technology partners that we have. The first one being Leica on the top right corner. Leica, we partner and we do sell, implement, and consult using the BLK360. So the Leica BLK360 is literally the machine that you're seeing on your screen there. It can fit in the palm of your hand. It's really small, compact, used a lot by interior designers, architects to scan the as-built environment to produce a point cloud, import, process, and model. So really good. We've used it on a lot of scan to boom workflows. I myself personally have been dealing with this, and it works really great. When it comes to more rugged applications, so construction and mining, we've got the Topcon GLS 2000. Very rugged, very much more bigger and much more greater range of scanning, with the entry level starting at a 350-meter extent, and the top end or top range being going up to a scan range of 500 meters, which is quite a lot. Okay, and then today's webinar is going to be focusing, or this series is going to be structured around utilizing IDAS into Civil 3D for much more efficient design processing. It really is a game changer. If you are an avid Civil 3D user, or you're in the civil infrastructure space, you definitely need to incorporate this into your design processes because, well, let me not give too much away. I will let you see it just now when I'm doing a demo. And then of course, last but not least, CAD learning. CAD learning, personally from a design professional perspective, is a must. Reason being is, first of all, you can learn anytime that you'd like. It's an online portal where you would just log in Google or whatever you use, log in. There's pre-recorded videos on a variety of Autodesk software, so be it AutoCAD, Civil 3D, Plant 3D, Revit, Revit Structures, Recap, 3ds Max. The whole shabam is on there. And these videos help you or guide you to actually learn something on the go, or even to recap on a software that you haven't used for quite a long time. There's step-by-step videos. There's files you can download and also do while watching the videos. You can do a skills assessment where it'll help you to see your proficiency as you go or progress. It's really good, really a must have, and especially for times like these, you do need a tool like this to guide you if you're not going to be coming for face-to-face training and stuff like that. And then of course we base this on our skeleton, or our processes that actually back everything or support us. It's called the iAdopt. The iAdopt, in a nutshell, is we assess your current processes, we educate you or teach you how to fish, if I could put it that way, and we consult with you if things are just above your reach or out of your depth at the current stage. We do this by utilizing your people, we analyze your processes, we improve your technology, and this allows us to facilitate positive change management in your industry, organization, and design processes. Okay, so that's just about us. Um, let's look at Devotech. What is IDAS? So IDAS stands for Infrastructure Design Automation Suite. It is developed by the Devotech group of companies, right? And it, of course, is an add-in to Civil 3D, which you will see just now. The offices are based here in South Africa as well as in New Zealand, and we, as Baker Baynes, are a reseller of Devotech IDAS in South Africa. It's a really, really powerful BIM application. It has a lot of these benefits that you're seeing on the screen. The key one that we're going to be looking at for this series is the pipe network analysis that runs directly in the Civil 3D interface. Now, if you've used Civil 3D by default, you should know that once you do your pipe networks, first of all, it's not that dynamic, but I do see that the 2021 updates are really, really good, so check them out. But in terms of the analysis, you would still need to export it to storm and sanitary analysis, do your calculations or your analysis, and then bring it back into Civil 3D. And there's a lot of confusion or loss of interest between that step, uh, especially amongst users, because the interface is completely different to Civil 3D. And this is where IDAS is beautiful, because you do everything in Civil 3D. You don't have to export, import, all of that is cut out. Also, in terms of the other things or other applications you can use it for, those are like survey and surfaces, platform design, urban roads. Roads, it's also really, really good. You'll see just now. And you can do single and dual carriageways with it, stormwater design, sewer design, and also bulk retics and stuff like that. If you want to download it from their website, I just put a snapshot of the website on the right hand side. You can go to their website, it's devotechgroup.com. Excuse me. And then, of course, we're going to be focusing on stormwater today. Okay, so out of the formalities, down with the fun part, which is the demo. So let's jump into part one and let's give you the project scenario and how IDAS actually looks. So currently, this is the project scenario. I created a site here in South Africa, in Johannesburg. I did that via the model builder in InfraWorks. So I modeled in InfraWorks. That's the model you're seeing on the right hand side. I imported that into Civil 3D, geolocated, and down the road. So the roads and everything are complete. It's just you would need now to focus purely on the stormwater to save time. So our requirements is we need to model the stormwater, we need to analyze it, and then also we need to do the drawing and production, quantification. With today focusing on that. So today we are there. So let's have a look at the model. So this is my model. Right, you can see it's quite a neat model. We've got two T intersections, we've got a curvy road. So it's an intermediate type of thing where I would say it's not just a straight road. So it's a very realistic type of example that I've taken. You can see there's intelligence stars attached to this model, and we can even check the cross sections out. You can see we can step through the road as we are going through it if needed be, and you can see it's a really good model, good place to start off in. Now, when you link this into Civil 3D, I'm just going to link in the alignments and I'm going to generate the corridors using the IDAS tools. Like I said, you can use it for roads. And there is a topo surface here, which you can see. All right. So let's take this into Civil 3D. So once I imported this in Civil 3D, this is how it looks. And I use the InfraWorks button there and I opened the model and I linked it in. Simple as that. And this is how we've done. These are the roads finalized, done and dusted. We just need to focus on the stormwater. Those are the road profiles or the long sections, and these are the cross sections. As you can see, I've used the our South African content here. So it's a SABS figure 8 curb, which is amazing. We got that linked in there. You can see it's exactly like our specs here in South Africa, and I've attached it to the cross sections and stuff I would use in Civil 3D for the targeting, and of course these are the long sections. Now, another cool thing I want to show you is the geolocation. So if you think that we are not working here in South Africa, I'm going to prove it to you. Just in case you don't take my word for it, right? I'm going to put the geolocation on. Just give it a few seconds. It will process. It'll should be there. Here we go. Right. So as you can see, there's the site. It's a real site. The topo is overlaid there. And if you look here, that's actually Mall of Africa. Let's just zoom in a little bit more. Here we go. That is Mall of Africa. So it is here in Johannesburg. And then of course there's the PwC building there. All right, so I'm just gonna switch that off. I just wanted to show you because a lot of people think you can't geolocate with Civil 3D. All right, but IDOS has the conversion for it as well, in case you are worried about the coordinate transformations and stuff. You can do it with Civil 3D, but IDOS has the tool to make it much more easier. So in terms of the roads, I'm using the Devotech IDOS template. There's it there. Wood partless, meaning that the pipe catalogs are a part of the actual template. All right, that's basic Civil 3D etiquette where you'll use that. And there's the IDOS tab there. Once you install it, you'll have an extra tab. These are all of the tools that you would need or you would have at your disposal. Really good tools, utilities, design. You can see there's roads, alignments, profiles, corridors, there's water, intersections. So I generated the roads using the intersections and corridor wizard. Also, in terms of the templates folder, I just want to show you this. When you install IDOS, you have templates for different versions of Civil 3D, which is good, with partless and without partless. The partless ones will be a much more bigger file and heavier to load, and the other one a little bit less. All right. Anyway, if we go to the support folder, these are all the content that comes with IDOS. You got the help file, which is really great, but I want to show you the assemblies. So if we open this Civil 3D assemblies, these are all the South African content or the curbs that have been generated already. So we don't have to go and create it from scratch. And we don't have to worry that the dimensions are wrong and whatever. You can see SABS. These are all of the actual curbings that are on there. Really good. Figure 3, figure 5. You can see. I don't have to. Here we go. You can see all of these assemblies are or sub assemblies are actually done. These can be attached to your current cross section that you would use. There's also some generic pavement structures below this. So again, all of the curves are on here that you would normally use. These are the generic road structures that you would use. You can see the intersection types are also there. You've got the staggered layers below this, and of course you've got a sanral detail that you can use. We all know how strict they are in terms of their submissions, and you can actually use this to help you design much more efficiently on the roads part. Maybe later on when we're done with all the water stuff, we could probably look at a series on road design. Let me know what you think. Okay, so this is where we are. Again, you can go in, there's a lot of support, a lot of things that you can actually get to, but today we are focusing on storm. All right, so that's about it. Okay, so that's a scenario that'll give you the project background. The next thing we're going to look at is the catchments, how we can apply the catchments to get the positions or the low points, because the low points are where we're going to insert the curb inlets. So let's have a look. So here we are. Before we start, I want to show you the catalogs that are already in with the template that I used. Here we go. So there's Stormwater. If I go and check the parts list, right, let's have a look. So if we go to pipes, you can see these are all the pipe lists or pipe catalogs normally used here in South Africa. Rockler is a very popular one, and we're going to be using Rockler for this design purpose or this demo. Again, same with the structures. You got eThekwini there as well. You got Tshwane. You got GRA also. So you've got a huge variety of content that you can actually use. So this is amazing. It helps us with our costing quantifications and stuff like that. All right, so we're going to be using that. Now, we're going to be doing the stormwater for these roads that you're seeing here, but we first need to get an idea of the elevation. So let's go to surfaces. What we're going to do is we're going to put an elevation banding on, or an elevation heat map, whatever you want to call it, the mapping, whichever word you use. And this is going to give us a general feel of the actual terrain. This is a standard Civil 3D command. People don't use it, but it's very effective. If I hit OK, you can see there it is. And the purple is the steepest part of the site, and it's going to be sloping down to the bottom here, right there. So I will want my outfall to be somewhere there, right? Because we want gravity to do most of the work. All right, so let's just go back to that menu. You can see it gives you the elevation key there that you can actually generate if you'd like as a table. But what we're going to do now is we're going to actually generate the watersheds. So what is a watershed? Watersheds are going to allow us or give us a pipe style, or so not a pipe style but rather a surface style, showing us the flow of water along the surface depending on the topography. And there it is. As you can see, the arrows give a good indication how the water would flow on the site. It's really helpful, especially if you are a water professional. And I still find this a difficult part. I remember doing it on Google Earth, doing the catchments and stuff, getting the area and stuff. But now you can actually do it directly into your design model, which is amazing and it's much more accurate compared to Google. Okay, so we're gonna actually outfall to the bottom there, which is great. Yeah, so you can have an idea how it's gonna be flowing down there, how it's gonna behave at the intersections and stuff. So let's go and generate the catchments. So we're gonna go to analysis and we're gonna run the catchments. You see there is a watershed to generate the crest. We're gonna make that 0.1, which is gonna help us calculate it better. Hit OK, and here we are. We have calculated the effective areas, or the catchments rather, right, or the watersheds. Different words, same thing, more or less, right? And you can see there's a common crest on the top, and this is where the water slopes differently from that point. So you see it's flowing down there, it's flowing down there, and then it's flowing to the side, or it's more slanted or tilted or angled to that way. And you can see this is where the water is going to come down. Most of the water is going to be flowing away on that side, which is great. But we just have to worry about that row there at the bottom, but it's still draining to the bottom. So it still tallies with the elevation mapping that we had previously. Those symbols indicate that there's a low point there, so that's a draining point. Right, it's really helpful for the inlets, and we're going to use them to help us position it. Okay, and you're going to see just now how we are about to do that. So now that we are here, I'm going to draw a circle. So this is the workflow that we recommend. You have your own, so I would like to hear how you currently do this. But what I'm going to do is I'm going to do a circle, and I'm going to make it a much more bolder. And what I mean by that is just the thickness, so that it stands out in our plan. Right, so here we are. I think that should be fine. And I'm going to copy this circle to the positions where I want to position a possible inlet for the road, where I think the curb inlet will be suited. Like for example here, you can see it's going to flow down the curbing channel, and we're going to come there. So we're going to need an inlet there before it actually reaches the curb below it. Right, so let's just copy, and this is the process or the methodology that I'm going to be applying. So here we are. Now you can see how much easier the arrows make it, because now you can actually see where you want to position stuff. So I'm maybe gonna have, no, not really there. I'm just gonna pan in. So there's gonna be a lot of panning and zooming. I'm doing it as if you would do it in a consulting office. All right, this is more or less how you would do it. I'm gonna drop one there. The two are very closely. That could be a surface discrepancy, so you'll need to apply your engineering judgment. Of course, all design needs engineering judgment, so don't solely rely on the software. That's but risky sometimes. If your input is bad, your design's gonna come out bad. Right, so let's drop one maybe there, because we want to stop the water coming down from the top there. All right, so here we are. I'm gonna drop another one there at that low point. Great. Here, let's see what's going on. Maybe one just before the actual intersection, maybe somewhere there. I think that'll be good, because we're gonna have the Swanee inlet coming in there with the 5 meter spacing. You will see what I'm talking about just now, because for this example we are using all local catalogs, right? Okay, I'm gonna place one maybe there, because I want to project the aquaplaning or negate the chances of aquaplaning at the intersections especially. All right, I think those are fine. Let's see where else here. Maybe I think, yeah, should actually drop one in there. All right, we're gonna come in here. Let's see, that's actually flowing away. That's not going to be that much of a problem. uh, let's look at the flow coming down here. All right, so that's all going to fall away from the road with the camber, or the channel is going to actually help it. I'm going to throw one in there because of the water coming from the top, and then the other low point. Again, I got two low points here. Again, I'm going to use that one because the water's falling away from the road at that section there. We're going to go here, maybe put another one here on the curve or just before the curve. Let's drop it here. It's fine. All right, we'll model that just now with the polyline. And then, of course, you can see what's happening there. It's more or less we need one before that curving. So that water's going to flow down there. We're going to drop it somewhere, maybe there, right? And then let's see if there's anywhere else I would line an inlet. That's gonna be fine. I think I'm gonna need an inlet coming down here because that's gonna be a lot of water that's gonna be coming or traversing down there. So let's see. Let's have one more look if there's anywhere else. I think that should be fine. Let's just delete this. All right, and here we are. Okay. Those big circles, I think I press enter too many times. But yeah, this is what we have. This is going to serve as a legend to where we're going to have our inlet curves. Now we're going to draw the polylines. So let's draw the polylines. So I'm going to create a layer. All right. I am going to call it ACAD Stormwater Polyline. And I'm also going to increase the line weight. Let's use cyan here. I'm kind of bad with colors, but let's just go with cyan. Let's go and line weight, I think maybe 0.6. Yeah, 0.6. Let's use that one. And we're going to make it a current layer. And we're going to close this. Right, you can see it's current, it's set. Now, the thing that we're going to need to be doing here now is going to actually be plotting. So I'm just going to type in PL for polyline shortcuts, keyboard shortcuts, right? Same as AutoCAD. All right, let's select it there. And we're going to start drafting or drawing it. So I'm going to start maybe there. You can see I've drawn I've got offset lines that I'm going to be following, so make it look much more neater, especially if you have a certain offset that you would need from the center line of the road. So in this case, all the lane widths were 2.5 meters on either side of the center line, and I needed a further 1.5 meters from the edge of travelway of the edge of the road as an offset. So this is where the polylines come in. You can create an offset alignment and you can trace the polyline over them to keep to it as much as possible. So here we are. As you can notice, I'm going in the direction of the flow as well because I went from top to the bottom, and now the water is going to flow from that corner to that vertices there. All right, or that junction. And the same thing here. Rule of thumb is your polyline must be or should be drawn in the direction of the flow. Make life easier. You'll see why just now. All right, so we're going to draw there. The water is going to be flowing down there and it's going to be tapping in there. Um, but it does happen where sometimes you will draw it in the wrong direction. Don't worry, I'm going to do that on purpose. So I'm going to do a lot of mistakes in here as well to show you how to solve them in the office, because when you're under pressure, you're just worried about plotting and you're not actually worried about process sometimes. Okay, so here we're coming to the actual low points. Here we are. I'm just gonna, you can see I've got my nearest snap on. It doesn't have to be exact, but if you're working really, really precise in the office, or you've got a very, very rigid spacing that you would need, then put your snaps on. And I'm gonna have my outfall there. As you can see, the arrows go with it perfectly. All right, so we did that branch as well. Let's do another polyline branch. So let's do the one coming down. So here the water is going to be flowing from about, let's say there. I'm going to have a manhole, drop in there, come into the curb inlet, or just come into the curb rather. I'm going to tap there. It looks close on screen, but it's in meters, right? You'll see it's quite, the pipe lengths are quite much, but you will, when we do the optimization, it'll be pretty good. Right, and I'm going to tap in at that junction. So let's just close in there. Great. Also, you're going to see certain places I haven't clicked exactly, just to show that when we go back, we can edit them to show you that you don't have to worry that you have to delete the polyline and start again, because I know a lot of people do that. You don't have to. So let's do another polyline. So on purpose, I'm going to go against the direction here. So I'm going to start there and go there, right? So as you can see, the water or the direction is wrong according to the flow, but I'm doing it on purpose to show you how to fix it. And let's do this one against it as well. So we're going to go and click there, right? And we're going to go down. Whereas the water needs to actually move in the opposite direction, right? You need to move upwards so that it can drain towards our outfall point that we want further down. And over here we're gonna also tap in there. You can see that we're linking it, but there's no vertices, there's no square grips there. There has to be a point or a vertices there so that a junction can be dropped in or a structure can be dropped in. And as you can see, we've got this one more here. I'm just gonna join this to this one. You can see I went a bit over at the bottom there, or close to the structure, but we can fix that. So I can either go across there or I can join. I think I'm just gonna go across there. Let's see, should I go across there or should I, either one, right? You'll have to use your judgment here. Depending on your experience, you'll know better. You'll also know the conditions, the spacing, construction requirements, those type of things. So that's where I went over. So I'm just going to sort that. And I think I'm going to actually bring this here to avoid going across the road. So again, right, you see I did erase that one because it's a small segment. It doesn't make a problem, to show you that you can erase it as well. So I'm also displaying the basic functionalities that are built in. It's not rigid anymore, so that'll be fine. Also, in practice, you would like your low point to be at the correct position relative to your road so that the water all drains to that point before reaching the road. So I think we're good. I think we are more or less done. Let's just have an overlook. Yeah, all good. All right, next thing is we're going to generate the pipe network using the IDA Stormwater Wizard. This is where the magic happens, right? So we're going to take the polylines. As you can see, we're just going to fix a few things. Like I mentioned previously, you can see that vertices actually needs to be there because I'm doing this very quickly just to give you an idea of the functionality and the methodology that you would need to apply there. All right, let's just see where else. If you click here, you can see there's no vertices. That is a problem if you're going to run your analysis, but there is a way to fix it, especially when you receive the polyline from someone else. If you xrev it or someone sends it to you to give you a general layout to get you going, if you run analysis without that, you're going to get errors, or you're going to get, if vertices are over each other, you're going to get a zero length pipe. But what we're going to do is we're going to use a utilities called map cleanup. It's part of map 3D, but the cool thing is I just brought it into the menu here, so it's easy accessible. I'm going to process all the entities on stormwater layer that I've created. I'm going to select them. I'm going to hit next. And what we're going to do is we're going to select the break crossing objects, hit next, and hit finish. Now what this does is now it adds a vertices to every intersection point. You can see that happened because I clicked at the wrong place, so we can always adjust that. Let's click there, and I'm going to drag that vertices, all right, or rather put my intersection snap on. Here we go, all good, right? Let's have a look at this one we looked at. Now you see that there's a vertices. That's what I mean. Wherever there's a change in direction or there's a join point, if I could, that's the simplest way I can describe it. You would need a vertices to be there, a vertex point, right? So here we are. We've got that. We got it done and dusted. Not sewer. Sorry, wrong one. Let's go to Stormwater Wizard. So you'll have to check that first before you come here. Once that's sorted, we give it a name. So I'm going to say Stormwater Network 1. Yeah, 1 will be fine. You can see I've got my site. I've selected my manholes here. You can select it from a long list, whatever you'd like. I think 600 pipe for now would be fine. I want to only process the layers in this. You can see layer is important for functionality, easier. I'm going to select this so it filters it out. Hit enter and give it a few seconds, and you should see now that the pipe network has been generated with the structures. So currently here we are. We'll clean this up a bit so you can see the structures are much more better, but you can see they are generated, but all of them are created using manholes. we are going to need to change the ones that we have circled to have the inlet structures rather than the manholes. So you can see where the circles come in. All right, so the next part is applying network labels and checking the flow direction. So before we get there, let's check the actual direction. So if you remember, I created some of them purposefully in the wrong direction. So we are going to switch the surface off so we can see things much more better. Sometimes slips. Let's go to no display. Here we go, click done. Right, it's much more cleaner and much more better for everyone who's following to look at. Okay, but you can see how helpful that is. Now what we're going to do is, if we look at the network itself, we're going to be changing the structures that are circled, but we want to know the flow direction. You can display this using the network labels, right? You can see there's a lot of, you can add, I want the direction arrow, and I'm going to go select the network and let's see what happens. So let's click there. Here we are, you can see the yellow arrow, and it also labels the manholes, but everything is currently labeled as manholes. It's not the case, but we're gonna sort that out just now. All right, but you can see everything's flowing in the direction I want to that common point. That's coming down. There's an arrow there, it's coming, flowing down there, coming to that point, to that manhole, and then discharging to the outfall. um, See, that one is wrong. That should be flowing in the opposite direction, right? So flowing up that way, that's what we needed to do. And then of course this also, so we did two in the wrong direction, and this can happen. It's a common mistake, and it's acceptable. Reason being is, if you're under pressure, you're just going to draw a polyline as long as it represents the layout. But we've got a cool thing called swap direction and flow directions. So we're going to use flow directions first. I hit OK, and what we can do is we can let the software confirm if our low point is good, and it's going to use the structure with the lowest elevation as the outfall. So let it process, it'll analyze everything depending on the topo and your network that you've plotted, and you can see now the direction has been changed. Sometimes, or very seldomly, this might happen where some might not update, like that one. I'm not sure why it didn't. If you do have this problem, and it very seldomly happens, honestly, but if you go here, you've got the option to say swap direction. You're going to use start and end structures, and we're just going to click on the pipe, hit enter, and done. Here we go. Right, now everything is correct. All right, and you can see that the structure at the bottom has changed because it has become an outfall. All right, so that's more or less what we need to do. Right, so now we know that the direction is correct. The next thing that we're going to need to do is the actual inserting of the curb inlets where we had put or positioned those red circles. So let's have a look. All right, so here we are. We've got the parts, and I'm going to use a South African. Let's use Swane, the low point structure for this. So that's where I'm going to put a low point or an inlet. I'm actually going to add some extra ones to show you that you can swap them further. So a lot of people think that if you keep using the function, that the software bombs out, or that's typically the case with a lot of add-ons. Not in this case. So I'm going to do a lot of things on purpose, right? So that you know that if you do make mistakes, you are covered. I mean, we all do have that problem where sometimes we will make a mistake depending on pressure. Like, see here, right? So look at this part of it. I've got two structures there. It should not be the case, and they're on top of each other. You see that? We're going to sort that out. Don't worry. That can happen if you have two vertices too close to each other or something like that. Here it's fine because we're going to have an inlet, and then we're going to have a manhole in the center. So don't worry about that. That's going to be good. So I'm going to change that into an inlet, another circle. Actually, we shouldn't be doing that as an inlet. I'm not going to click on that. All right, but I'm just going to show you. So Once you select all the objects that you want and you hit enter, give it a few seconds, done. There's your inlet structures. Now you can see you will need to position them properly, all right? And that is a very easy task. So easy. Okay, it'll take you a few minutes to do that. So here we are. You see we still got some manholes in. I didn't update all of these ones, especially the ones at the intersection, because I want to use the Swanee curb inlet for that, where the regulation says that you need to be 5 meters positioned, or it needs to be positioned 5 meters prior to the actual bell mouth of the intersection. In terms of the positioning, you've got two grips, right? But what we're going to do is we're going to delete this structure first. This is where we had that double structure. So let's delete it. So we go to the top here, we say delete structure, we click on it, and it's going to ask you to which pipe you want. Always keep the longer segment of pipe. Delete that, and we're good. Here we go. Done. Right? And now we're just going to need to adjust the orientation of this. So we'll use a circular grip to just rotate it. So you can eyeball this. It works really great. Have your nearest snap on, and that's it. Looks really good. All right. Again, you'll need to do this for the rest of the structures, which wouldn't take you a long time, and it works really easy. It looks really good. All right. So let's go in here. Let's position this really nicely along the road. All right, maybe neatly along the road edge. You can see this is good. All right. So we've got all of these things that are tapping in there. You can see even the offset, the reason why you have an offset, because I did the offset alignments, if you remember or you recall, and this is why it fits in really good. All right, so I'm going to change that one to a curb inlet as well. These are all low points, normal low point curb inlets. I'm going to change that one as well. Let it go. Let's see what else. So this is more or less exactly the same process you will use in a consulting office. Whether you're a draftsman, whether you're designing it yourself, this is the same procedure. You'll have to draw it. You'll have to zoom in, zoom out. The bigger the screen, the better, I would say, for personal experience. You get to zoom in things much more better. All right, so this is what we'll have to do. I'm not going to do every single structure here, all right, but you get the gist of it in terms of the positioning. I think I'm just going to change this. I don't want this to be a curb inlet. That should actually be a manhole, all right? Uh, Manhole should be definitely be there. So let's swap that. So you can see I've been deleting and swapping and moving a lot of structures, and the software is quite fine. All right. So here we are. I'm going to use 1,000 millimeter Rockler manhole, what we're currently using. I'm going to select the parts or the structures I want to change. Maybe let's change. Let's see, which other ones do we want to change here? Okay, let's just do that one there. All right, let's hit enter. All right, and we'll do that one too. Fine. Hit enter. Man, every time I want to hit enter, I'm just looking. All right, let me just look. Here we go, enter, done. All right. Okay, so you can see it has updated to the manholes, all good. And I want to swap a few more structures. So if we go to Swanee, since we are using this stuff, I want to show you this. So you got left, LH stands for left hand, RH right hand, and you've got different structures with different widths or catch width values, right? Different transitions and stuff like that. So if I insert this here, right, so that's fine. The same kind of structure we're using. Yeah, I don't need those circles anymore. I'm just gonna delete them. I know what's going on now, right? So you can see the circles also help. Sometimes it's just practical working that helps you. It doesn't, not really the technology that much. You just need a plan, man. You have to plan, right? So here we are, but you'll get a hang of it as you design more and more and you get involved more. So here we are. We got that. See, it sits really, really good, really nicely on the edges. All right. So here we are at the intersection. This one's I'm going to use different structures. Okay. Again, I haven't positioned all the structures because it's repetitive and you can't see I can do so, right? Pretty easily, and you can as well. So let's go and select the an inlet with a set distance away from the bell mount. You're gonna really like this, especially if you're in transport, right? So let's go. Okay, I'm gonna swap that one, right? Okay, I think I selected the wrong side. Um, Let me just swap that again. So you can see, even if you're using the catalog for the first time, you can swap things very fast and very easily. Okay, so here we are. It's actually going to be a right hand side, and perfect. Okay. There's a ruler. So this ruler is in meters, and it actually helps you to see how far you are from the bell mount. That looks good enough, between 4 and 5 meters. That's why it's red. Okay, so between there, and you can see it sits in there correctly. Also, when you're printing, that ruler will not come out because it's in a no plot layer. So again, AutoCAD coming back in here, so it won't plot. So don't worry about it coming out in your drawing. It's not going to come out. Okay, again, I'll just position that. All right, and we can actually put more structures in here. Let me just put this back. I know I said I'm not going to do all, but I don't like seeing stuff like this. Even I know it is a demo and you want to save time, but yeah, I'm a bit weird like that. But anyway, um, I'll try not to do all just to save time. We are back here at the intersection. We've put that one. I think we need to put another one here. All right. And I think from experience or from knowing the software, that's a bit too close to the intersection bell mount. But let's see. Here we are. Again, I've swapped it again wrong. And I'm supposed to be using a left hand side. All right, here we go. Swap it. All right, select the structure, enter, done. Right, so we've got this, and I'm just going to position it. And as I expected, that's too close to the bell mount. It should be at 5 meters from the start of the bell mount. So I'm going to move this. So you can see how insightful this is. That's why I used the word initially uh, on the introduction of this webinar series. It is very insightful. That looks about fine. I'm going to use a good eyeball snap. Perfect. 100. All right, so we are good there. And this is how you will actually position your structures. Again, you can go and use all those other different functions. It works exactly the same methodology, just different applications. So now that we've inserted the structures, I know I didn't finish position all of them, but you got the idea. We need to update the network labels. What I mean by that, let's have a look. So as you can see here, even though those are inlets, it still says manhole, MH for manhole. That's wrong. We need to actually update that because we swapped the structures, but the labels didn't update. It's a very easy way to do it. Now, normally it's a nightmare when you did it manually. I remember those days, it was bad, right? But what we're going to do is we're going to use the Stormwater Manager in IDAS, and I'm just going to go to options here quickly and go to rename settings. Those are the prefixes. You can edit them if you like, but they're quite good. MH manhole, KI curb inlet. If I hit renumber, you can see it updated all of them. And if I zoom in, you can already see it has updated that curb inlet to say KI8, for example. All right, the label has updated. Also, this when you're drawing a polyline in the correct order, it helps with the numbering or labeling, right? So it'll label it more or less sequentially. So if you're happy with this, you can actually go and start doing your production stuff if you want to. But if you want it sequentially, I'm going to show you now. But what we'll do is I'm going to switch off the arrows, and I'm going to use a label convention where it shows the pipe name and the diameter. I normally just display diameter because it does get a bit cluttered, but if you have a long network, it's perfect to display it. Here it'll look a bit cluttered because it's a small road network, but I'm just going to apply it to show you. And here we are. The diameter is 600 as we specified. You can move it. That's pipe 20, and you can actually position it however you'd like. Right? So I just undo there. And then what we're going to do here is we are going to have a look now how we're going to actually label this sequentially. right? So let's use this as an example. Let's say I wanted MH10 to actually be MH1. I wanted MH8 to be MH2 manhole 2 and to tap into that network of KI8, right? So that order there. What I'm going to do is there's an option that you can use. So if we go to Civil 3D interface and if we go to show menu bar, it'll actually group the functions by element. So if I go to pipes, utilities, and I go to rename network parts, I'll rename the start of the select the start of the branch and I'll end it there. I won't select the structure because I want it to end there. It's not part of the branch. All right. So this is where you can label it. I'm gonna call it MH1 point. So this will mean that it's the manhole on network on branch 1, manhole 1, branch 2, same here. So pipe 1, it's on network 1, P1, network 1, and it's the first pipe. P1.2, second pipe. So let me do it and see. Here we are. So you see it has updated. Manhole 1.1 is also got pipe 1.1. So it's network 1, pipe 1. Manhole 1, network 1, manhole 2, stuff like that. You'll have to do this for each of the branches and it will update. If it labels it will label everything according to manhole or KI, but then you will just need to use your Autodesk, your quick properties and edit the labels like that. Right, so that's about it for the modeling part. Let's wrap things up and get you going with your day. So we covered a lot, and I've been speaking a lot normally for these type of webinars because they are very technical in nature. So if you don't have that much of a background on it, you can always reach out to me. I can always try and explain things to you or help you out on the design methodology part of it, right? Alternatively, there's a lot of content on civil engineering blogs and stuff like that to help you understand how stormwater design works, just the theoretical background. But I hope you all found this very useful. I see the comments are really great, so thank you very much. A lot of people saying it's very insightful. I can see there is some questions in the question box, but we'll get to that at the end. It's a bit difficult answering the questions while you on a technical trail of thought, right? So this is what we did. We did the Infrarex model on the right there, as you can see. We imported into Civil 3D. We generated the catchments. We figured out the low points. We dropped in the curb inlet positions with those circles. We drew in the polyline. From the polyline, we checked the directions. We used the map cleanup. Then we did the network. We created the network. We swapped the structures, and we created the labeling. That's quite a lot. We actually did more than that, what I'm saying, but we did it exactly the way that you would do it in a consulting office, which is great. So if you ever feel lost, always come back to this video and you will be good to go. Also, I'm going to give you my contacts right now where you can reach out to us or to me directly and we can help you out. So if you want to connect with us on Baker Baynes online, these are all our handles: LinkedIn, Facebook, Twitter, Instagram, and YouTube. I'll touch on YouTube just now, but just type in Baker Baynes and follow us, subscribe so you can be connected. We host a lot of webinars. So I do the webinars in civil infrastructure, mining, structural, and also builds, and the 3D laser scanning part of things. We also got professionals that are in the architecture space, so they will host all of your architectural webinars. We've got professionals in the product design, manufacturing, energy, plant. So depending if you want to keep in contact with what's happening, even in other segments, please subscribe, especially to our YouTube channel and LinkedIn, because all of these updates and webinars are posted there. And of course, as Captain America would say in Avengers, he will say Avengers Assemble. I would say Designers Assemble. I would really want to connect to all of you, right? So as you can see, my webinars are very informal and chilled. It's not very formal language that you would normally hear in a design webinar, because I want to relate to your experiences as a designer much more better. And since I am one, it's much more easy to come across like this, and the feedback also suggests that. So thank you very much. Uh, who I am Shoaib Yunus. I'm the BIM technical specialist here at Baker Baynes, specializing in civil infrastructure and mining. So it's if you want to reach out to me, anything civil infrastructure design, you're more than welcome to hit me up. My primary focus, if you want to break it down according to software or products, design software, these are the ones I really use on a regular basis. So Civil 3D, InfraWorks, Recap, uh, Cyclone should actually be on there as well. Vehicle tracking, AutoCAD, BIM 360, and of course laser scanning. So there's Topcon and Leica. I'm also using that. In terms of secondary, structural, because like I said, I do have a civil engineering consulting background. I do consulting. Um, these are the products. So steel modeling, structure, rebar, concrete. Those are predominantly structural projects or products, and of course Navisworks to more or less coordinate everything. You can reach me on LinkedIn or hit me up on LinkedIn if you want to have any suggestions, if you have any questions, if you want to find out about anything, or if you just want to say hi and connect. I'm more than friendly and more than welcome to do it. Just type in my name and then add me. Also follow me because I post all of my webinars on there when they are updated. So if you want to also email me, you're more than welcome. That's my work email, shoaib@bakerbaynes.com. If you have any webinar topics that you would like to recommend me to tackle, I'm all ears. It's always great to hear from industry. Also, it'll help you because it is something you kind of hit a brick wall and you can't get through, or you're always frustrated because it takes you too much time or it's just not good. Drop me an email or, like I said, LinkedIn. We can chat about it. I can find out more about it, and we could probably do a webinar to tackle or show how the best way to go about it, so you can incorporate it into your own design processes. And then last but not least, webinar recordings are all uploaded to the Baker Baines YouTube channel. Now, I'm looking at the chat box here and the questions. The thing is, a lot of people are asking for the recording, and a lot of people are like, their friends or some of their buddies couldn't make it for some reason because they had deadlines. That's all good. So how we work with it is, I would strongly recommend you to register. Even if you feel you're not going to be able to attend, there's a slight chance you will attend. Register. Reason being is, as soon as the webinar is done and it's uploaded, the content, or once it's uploaded to YouTube, you will get an email notification to say, hey, there's the webinar because you registered for it. Here's the link to the YouTube webinar. You can go and share that link and watch it again and have a recap. So it's really good way to get it directly into your inbox. Alternatively, I post it on LinkedIn after this. So once this is uploaded, I will post it so you can tag a friend. The cool thing I saw at this webinar is a lot of people tagged fellow professionals, and that is amazing because we want to actually develop and up the design capabilities here in South Africa. And we got the skill set, we got the knowledge, and we can do it. So please in future also tag future designers or people that you would think that will benefit. Reshare the post. It is free learning, as you can see today, and we can get a larger following and much more insightful and intelligent designers out there. Yeah, so that's about it from me. I will post this again on LinkedIn. Let's just have a quick look at the question box if there's anything. Always great feedback from a lot of the users here. Thank you so much. I do appreciate it. It keeps us going and it helps us to more or less gauge if we are targeting on the right topics. And I see this one is really good. The attendance has been amazing, so really, really well done. But yeah, no real major questions. Um, okay, there's one here about the labeling. Is okay. So the question is, uh, are the labeling functions not built into Civil 3D? They are, right? So all those annotates. If you go to your annotate tab in Civil 3D, you will see most of the labeling there. However, most of the styles you will not see there because they are created for the Devotech template. If you go and download the trial from devotechgroup.com, or you can reach out to me, you can download the template for free and then you can use it into your old applications. The styles are already pre-built there. You already saw how much of the curb inlets are already, or the curbing has been done. So it's a really, really, really good way to use or apply it to your Civil 3D. Really good template. Right, so yeah, the annotate is there. And there's one more question regarding the reversing direction. Okay, good question. This is, thank you. So in Civil 3D, you can also reverse the direction of the flow, like I showed you initially. But we've picked up that it only updates the label and the structures stay the same. it does work sometimes. It's very risky. So this is why IDIS is much better, because IDIS updates the label as well as the pipe layout when you're laying or you're connecting the structures. So just be careful about that. Very good question. Thank you so much for that. Yeah, I think that's about it for the questions. Again, if you want to reach out, there's my email on the screen, there's my LinkedIn. Feel free to drop us an email. And if your buddy couldn't make it, tag them today. I will post this out on LinkedIn soon so you can reshare it and people can be designing in a much more intelligent way. So thank you very much for joining today's part one of the Stormwater design series. I see it is has been a success, and I will gladly be looking forward to looking at part two, seeing you over at part two, where we're going to be looking at the analysis, long sections, and those type of things. Thank you so much. Have a great day, and see you soon for part two.